All right, everybody, welcome to Earth Science. So did you think about how to try to measure these three things? I think what I'll do here is a video for the method. Let's talk about how we'll actually do this. Let me know if you came up with a better way or if you agree with my way. And then I'll do three separate videos to run through it for the three separate sizes. So I know that sounds long and intimidating, but we'll get there. Keep working. All right, so I got my setup all ready to go here. And let's think about it. Porosity. How much space is there in between the beads? So here's the idea. I've got a measured amount of water, 800 milliliters of water. I measured exactly 400 milliliters of beads by doing displacement yesterday so that they had time to dry out. So I filled this up to 500, and then I dumped plastic beads in until it went up to 900, meaning that I have 400 milliliters of beads. And I've got those big, medium, and small all ready to go. What porosity is going to be then is how much is pore space compared to how much of that is material. So I know that, I don't know, don't worry about these variables looking kind of weird, VV and VT. It's all pretty straightforward as we start to figure this thing out, okay? Looks like I should probably do the smalls first. So I'll switch to smalls before we get moving here. So the procedure is going to be this. If I have 800 milliliters of water and I have this sealed off, if I just dump water in until it gets right to the top of the beads, which is way up here, and then I see how much water I have left in the cylinder, I'll know exactly how much I put in. People always come up with the idea that, okay, I'll put water in and then I'll take it back out and measure. But the problem is some is going to be stuck to the beads, which is actually an important idea when we get down to capillarity. But if I know how much I'm starting with and I fill it until it's full and then I look at what's left, then I can figure out how much is actually in there. Okay? So I don't want to make you guys write a million things. How can we say this in brief? So we'll say measure water, fill empty. You want to do it like a list. So it'll be measure water, fill empty space, see how much is left. And that's it. I mean, that's fine. We do a lot of writing with this. So, I mean, I know that this YouTube stuff is tedious, but this lab is actually going to be much faster and easier than past years. So something like that will be cool. All right. Now, like I said, my volume of material, VT, I'm starting with 400 milliliters. So we can go ahead and just fill those in right now if you want to. I'm going to make this a tiny bit smaller. 400. In fact, if I were nice, I would go ahead and put this on the lab before I give it to you. We'll see. We'll see if I'm nice by the time I print this. All right, so there you go. There's 400 milliliters of each, and that'll be that. We'll fill in water. We'll see how much space is left, and we'll be cool. All right. Next, permeability. There's a much more complicated way to do this in real life if you're really calculating permeabilities. We're going to just do it as a rate. It's essentially your rate of change problem, which is going to be distance over time. So what I'll do, after that first part, I'm going to have a whole bunch of water in this tube already. So all I'm going to do is first grab a meter stick and measure how tall the beads are. Second, open up this little valve right here, let the water drain out and time it. So distance, however far it is, divided by time is a rate, like your car does miles per hour. This will be in centimeters per second, but it's the same concept. It's a speed. And again, with the principle being which drains faster, which has a higher permeability, the big beads, the small beads, or is there no relationship at all? So we'll see. All right, so basically measure height of beads in column, time how long it takes for the water to drain. Close enough. Again, let's keep it simple this year since you're stuck doing it on YouTube. Okay, so distance, time, and then we'll divide them for permeability. No sweat. That'll be easy. Capillarity. How much water sticks to the particles? Well, I know how much water I put in there because I did that for the first procedure. I took a whole bunch of water out to time it for the second procedure, and that will be sitting in this beaker. So what I'll do then is say from my original, if I take that, dump it back in here, I know I started right here at 800 milliliters. Hopefully that's enough. But no matter what, I'll know where I started. And when I put all the water that came back out back in here, is not going to make it back to 800 because some of that water is going to be stuck to the beads. And I'll know exactly how much because I got a graduated cylinder sitting right here. So if I take 800 and I put it in, and I pour it back into here, and I end up with 750, then we're all clever enough to know, oh, well, those beads are still wet. They're holding on to 50 milliliters of water. Okay, that's it. So volume of pore space, we're actually going to steal from the first part. That'll be done. VS, volume of water stuck to the beads, is all we got to measure. Easy peasy. So this lab looks like big and intimidating, but really it's not so bad. So take water from, what do I want to say? Drained water, take from previous job. I don't know. Take the previous water, drained water from the previous job, dump back into original graduated cylinder, and then see how much is missing. See how much is missing. That's it. And we'll chuck those numbers, do a little bit of light division, and that'll be that. So again, this might look like a lot, but really once you get the concepts through your head, we'll whip right through these 3 experiments. Okay. All right, cool. Let's get it started in another video. I'm going to switch these out. I'll do smalls, then mediums, then larges. All right, we'll see you in a minute.